In this video, we will be solving question number 53 from GATE 2020 chemistry paper. Now the question is the following. At 30 degrees centigrade, the vapor pressure of density of a 1 molar aqueous solution of sucrose are 31.207 millimeter Hg and 1.1256 gram per ml respectively. So if the vapor pressure of the pure water at 30 degrees centigrade is 31.824 millimeter Hg, then we have to find the activity coefficient of water in the given solution. So the vapor pressure and the density of 1 molar sucrose solution is given, and the vapor pressure of pure water is also given at 30 degrees centigrade. Now we have to find the activity coefficient of water in the given solution. The molar mass of the sucrose is also given, 342.3 gram per mole. Now the expression of activity is A equal to P divided by P0, where A is the activity and P is the vapor pressure of the solution and P0 is the vapor pressure of the pure solvent. That means in this case the solvent is water. So the activity is basically the ratio of vapor pressure of the solution and the vapor pressure of the pure water. So vapor pressure of the pure water, that means P0 is given 31.824 millimeter Hg, and vapor pressure of the given solution, that means the 1 molar sucrose solution, is also given 31.207 millimeter Hg. So the activity of water in solution will be P divided by P0, that means 31.207 divided by 31.824, which will be equal to 0.98. Now we have to find the activity coefficient. So the expression is activity equal to some activity coefficient gamma times mole fraction of solvent in the solution x1. So here A is the activity, gamma is the activity coefficient, and x1 is the mole fraction of solvent, or in this case water, in the given solution. So we know the value of A, we know the we have to find the expression value of gamma. So gamma is A divided by x1. So A is known 0.98. Now we have to find the value of x1 to find the value of gamma. So let's find this. Okay, we know the expression of density equal to m times m divided by v. D is the density, m is the mass of the solution, total mass of the solution, and v is the total volume of the solution. Let's say in our solution m1 gram or m1 gram amount of solvent, that means water, is there, and m2 gram or m2 gram amount of solute, that means sucrose, is there. So total mass of the solution will be m1 plus m2. Now if we express this small m1 in terms of number of moles times the molar mass, so m1 will be n1 m1 plus n2 m2. So total mass will be, so n1 is the number of moles of the solvent, capital M1 is the molar mass of the solvent, that means water, n2 is the number of moles of solute, that means in this case it is sucrose, and capital M2 is the molar mass of the sucrose. Now if we replace m here with this expression, so density will be n1 m1 plus n2 m2 divided by volume of the solution. Now let's say so we know there are n2 mole of solute, that means sucrose, is there in our solution in VML solution. So in VML solution n2 mole of sucrose is there. So in 1000 ml solution, how many mole of sucrose will be there? N2 times 1000 divided by V. So this is the another expression of molarity, right? So molarity of the solution, that means let's say capital M. So molarity of this solution will be N2 times 1000 divided by V, where N2 is the number of moles of solute, in this case sucrose, times 1000 divided by V means the volume of the solution. V ml. So we know the expression of m is N2 times 1000 divided by V. So from this expression we can write down the N2 divided by V will be equal to m divided by 1000. So D in this expression of D, so D equal to N1 m1 divided by V plus N2 m2 divided by V. Now replace N2 by V with this term, so this will be m times m2 divided by 1000. So from this expression, if we extract the expression of N1, so N1 will be 1000 times density times volume minus volume of the solution times m. Capital M means molarity of the solution, molarity of the solution times m2, that means the molar mass of the solute divided by 1000 of m1. So the mole fraction of the solute, that means sucrose, in our case sucrose will be, let's say it is x2. So the expression of x2 is the number of moles of sucrose present in our solution, that means N2 divided by total number of moles. So total N1 number of moles of water is there and N2 number of moles of sucrose is there, so N1 plus N2. Now if we put all the expression of N1 and N2, then we can get the mole fraction of the sucrose. X2 will be m times m1 divided by 1000 times density minus m times m2 minus m1. Now we know all the values here. We know the molarity of the solution, that means 1 molar it is given. We know the molar mass of the solvent, that means water, 18 gram per mole. We know the density here, 1.1256 it is given. M also it is known. M2 molar mass of the sucrose it is also given in the question, and M1 is also known. So by putting all these values we can get the value of x2, that means mole fraction of solute or sucrose in our solution. So the value of x2 is 0.02246. Now we know that the total mole fraction of our solution has to be equal to 1. That means mole fraction of solvent plus mole fraction of solute has to be equal to 1. So chi1 plus chi2 equal to 1. So mole fraction of solvent, that means chi1, it will be equal to 1 minus mole fraction of solute, so that means chi2. So we know the value of chi2. By putting this value of chi2, we can get the value of mole fraction of solvent, that means water. So chi1 will be 0.97754. So mole fraction of solvent in sucrose solution is also available now. So the activity coefficient, that means gamma. So gamma was actually activity divided by mole fraction of solvent. So we previously got the value of A, which was equal to 0.98, and now we get the value of chi1, that means mole fraction of solvent. So by dividing this, so 0.98 divided by 0.97754, which is equal to 1.0025, and up to 3 decimal places we can approximate this. So 1.003, that means because the 5 is greater 5, after 2 the 5 is there, so we can approximate up to 3 decimal places is 1.003. So the activity coefficient of water in our sucrose solution will be 1.003. Thank you.